So now that you've done your hazard analysis, you've likely identified a process preventive control or two for your example food safety facility. And those process preventive controls, if you remember, we talked about it a little bit earlier when we were talking about the hazards, some different things that you might do within your processing to minimize, significantly reduce, or eliminate a hazard. So it might be something like a metal detector that rejects products with metal in it, or a sieve, which filters out any potential physical debris from your product. It could be something like an oven where you're cooking your product. So we have lots of different methods for process preventive controls. Maybe it's a pH measure, right? Or a combination of those things. So our process preventive controls, anytime we identify a hazard that requires a process preventive control, we're going to make sure that we have those procedures around it to ensure that it's functioning appropriately to control the hazard, and that we're doing that every single day. So for each process preventive control, I have to put those parameters and values around it, monitoring procedures, corrective actions, and verification and records. So for example, if my process preventive control is frying something up to cook it, my parameters and values are probably time and temperature. So how long is it being fried and how hot does it need to be? I'm going to be very specific about what time and temperature I list. Because these would be the critical limits, so it's safe versus unsafe. So usually it's not going to be an average, it's going to be like greater than 165 degrees or greater than or equal to 165 degrees for greater than or equal to 75 seconds, right? It has to be pretty specific. One mistake that people sometimes make is they get operating limits confused with critical limits. And operating limits are usually set around protecting your critical limit. So for example, say you have a trapeze artist, right? And that trapeze artist may have a net under them. So if they try to fly to the next trapeze bar and they don't catch, then they fall into the net. That net is an operating limit. If they were working without the net and they're not able to make that catch and they fall, that's a critical limit. So safe versus unsafe. So once we've decided those parameters and values, those critical limits, we look at how are we going to watch them on a regular basis to make sure we're maintaining safety, and that if we have potentially unsafe situation, we didn't meet those parameters, what are we going to do? Well, we have to have a corrective action. That means we put the product on hold, go back to the last good check. We have to figure out what the actual cause of the issue was and restore order. Then we go and evaluate the food and see, can it be saved? Can it not be? If we can rework it, we do. But if we can't, then we have to destroy it so it can't enter commerce. That means maybe burning it or burying it deep in a landfill, even destroying the packaging. Because if somebody gets hold of the packaging, then you are liable. And then after that, verification. So that's about making sure my system's working the way I intended it to. So it's going to be things like calibrating my thermometer and reviewing my records to make sure that my monitoring procedures are being done properly. Maybe it's reviewing my food safety plan to make sure that I wrote it correctly and it's still working. So maybe it's a self-audit. We have lots of different ways that we can verify our system. And then record keeping for each preventive control we have to have records around the parameters and values, the monitoring and the corrective actions, and the verification. So lots of records. In our EG Food Company example, our process preventive control is their cook step. So you remember we looked at the eggs? Well, we brought down from our hazard analysis form into our preventive control form this cook step. So step is cooking. The hazard is survival of pathogens such as salmonella. So that goes into our process control form. And now we get to fill out the rest of it. So how do I choose a critical limit? Remember, I said safe versus unsafe. I could have lots of different ways to choose how to make this safe versus unsafe. So I might have different options for controlling the hazard. Maybe it's a combination of pH and water activity. Maybe it's a combination of formulation, time, temperature, how long it's in the oven for, how thick the product is. So there are lots of different ways those critical limits can be written and addressed. The most important thing is that it has to be practical and achievable, right? So if I'm making chicken nuggets on a conveyor belt oven, it's not practical for me to take the temperature of every single chicken nugget, right? But what I can do is I can measure my belt speed, I can measure my oven temperature, I can measure the airflow in the oven, right? I can measure the thickness of that chicken nugget. All of those things are key to making sure that I have a cooked chicken nugget. And if I do a study to prove that if I maintain all those parameters that I am in fact killing salmonella, then I know that I have validated critical limits, all right? So they gotta be practical, they gotta be achievable. For EG Food Company, the critical limits that they chose were that the temperature has to be greater than or equal to 158 degrees Fahrenheit. Their time, instantaneous. So this, they pulled from a food safety code about how hot you have to cook egg for it to be safe. Now they get to decide the monitoring parts. So why do we monitor our process controls? It's essentially to track our processes. We can collect data. We can see if we have any trends, if we're increasingly having issues, or if we're doing really well. And it also gives us written documentation. So those records are the proof that we are actually following those preventive controls and that we're maintaining safety. So in our cook step, when we look at the monitoring for EG Food Company, the what is the omelet temperature being greater than or equal to 158 degrees Fahrenheit. The how is an infrared surface thermometer. Frequency is each cook station 4 times per shift, about every 2 to 3 hours. Now look how they wrote that. It's important. About every 2 to 3 hours gives you a lot of wiggle room. If you write every hour on the hour, that means that if I'm a minute ahead or a minute behind, I'm technically out of compliance. So whatever you write down is what you deemed critical to food safety. So give yourself wiggle room. Give yourself room for human, logistical, practical matters. Then who they put QA technician or designee. You can choose to write this however you want. The person who's doing the monitoring needs to be trained and understand food safety. They have to understand what the important parameters or values are around this area, why it's important that they're watching it, and most importantly, to raise the alarm when something goes wrong and you deviate from the critical limit. So that's one of the most common areas where people make mistakes. A new person gets put on the line, they don't understand what it means that they're deviating from a critical limit, and they don't report it because they're afraid they're going to get in trouble. So training is key. Your corrective action procedures. So I don't meet my critical limit. What do I do? I'm an AG Food Company and I don't hit 158 degrees Fahrenheit. So first you have to identify the problem. You have to correct the problem. This is after you've put the product on hold and you've stopped production, right? Because we don't want to be making more bad product. Then we reduce the likelihood of it happening again. You check the food. Is it something that can be made safe or is safe or not, right? So maybe I put the wrong label on and I can just relabel it. Great, I'm gonna do that. Then I need to make sure that no matter what I'm doing, any food that's not safe does not go out to that customer, right? That's the biggest thing. So we have to have very clearly written corrective action procedures that we plan ahead of time for what might go wrong. Now we're on to our next exercise. So you're going to use your hazard analysis from the previous exercise. And we're going to give you the answers for what the people who wrote the food safety plan decided the answers could potentially be. Now remember, these are teaching examples, so they're not 100% correct. They're not even built to be 100% correct. There are like some inherent intentional things that are wrong or different. It's probably different than yours, but it's just something to look at to help you move through the process and get a better understanding of how somebody might do a hazard analysis. Then, once you have that in your hand, or once you have it on your screen, rather, you're going to identify a process preventive control that was identified in the hazard analysis. So e.g. food company, they would use their cook step. Then you complete the process preventive control form for that one step in your plan, that one process preventive control. And you're going to fill out the critical limits, the parameters and values, the monitoring steps, and the corrective action. And you're going to stop there. So don't do the verification and the record keeping part. So things to think about. Well, how are you going to actually control the step, and what do you do to control the step? Make sure you work in some wiggle room with your wording. And you can use for information on your specific critical limits. There's Appendix 4 for microbial controls and critical limits. You can also use online resources. Just make sure you get as specific as possible. So if it's a number, I want that number, right? How do we kill E. coli in a chicken nugget? All right.